Hi everybody, welcome back to this WeeW tutorial, and today you will learn to use a serial EEPROM to create a data logger. So the example that we are going to build together will consist on a data logger or a time logger for this time. So each time that the STM32F1 will be restarted, it will take the data from the DS3231 and log it in the EEPROM memory. So each time we are going to restart, we will have a new record and including the date. So, and the data will be visualized using the UART communication and seen here. So if I restart again, you can see that I had a number of record which is 3, and this is the time when I restarted, and this is the last one. And let me click again. So it becomes 4, and I have all the log within the image board. So if you'd like to see how it works, just stay tuned. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. As usual, the code that we are going to write together is available on GitHub. You can find a link in the description below. We are going to use only the C language, and the program to code will be KL version 5. Finally, you may need to take a look on the previous tutorials for the I2C communication, as well as the real-time clock or also the EEPROM communication. Okay, so for the hardware we are going to use the blue pill, which is a STM32F1 base board, and also the FTTI, which will be used to make the UART communication with the computer. Finally, we are going to use this MH board, which is the AT24C serial EEPROM, and also a real-time clock. So for today, this is a part of an EEPROM tutorial, and this is a part 2. We are going to create a data time logger and visualize the UART. We visualize in the computer using a UART communication. And we are going to use both the DS3231 real-time clock and the AT24C EEPROM memory. So for the tutorial, we are going first to share with you how we are going to use the data logger logic, then have a last review of the MH board and time logger. After that, we are going to start coding, and we are making first the support functions, and this is the function that we will use later on in the future function in the same tutorial. So we are going to use them in the logger initializing function, and after that we are going to create a logger record function. Then we are going to make the logger read function, and finally we are stopping with a live example and debugging if needed. Okay, so the data logger logic. So we are going to take the first page of the EEPROM, which is divided by 32 byte by page, and we are going to put for each byte address a certain special data. So for example, the address 0 will be the version of this data logger logic. I'm thinking to improve in the future, so this is the version 1. And the address 1 and 2 will be how much memory is in this data logger. So the program in the future application will understand if we do have the memory or not. After that, the word size. So right now we are going to save only char, but maybe in the future we will need a bigger numbers, and we will need to divide if we do have an int or a short or whatever. So that's extremely important. Then the next information will be how many words in a record. Whatever we are going to use, a char, a short, integer, a long, how many of them will be in the same record, and we will need to keep this information so we are clear about the logic to extract and also to read. Okay, after that we are going to check how many times or how many record we do have, and this is an unsigned short or a short. So this is can be a number that be over 256 as 56. So it can be maybe we will need two char or 16 bits to save this data. After that, we will need also 2 other bit and to see 2 other byte, and this is to see how many the new address, the last address that we will need for saving. So we are going to implement in the first page all this data, and after that, using a certain logger logic, getting the data and start to record it in the other pages that we do have, or getting back the data and reading it to use it for a certain purpose. So this will be an overview of the picture, how the logic is going to be. So for the next step, reading will be, we will use the number of words in a record, and we will use this one to set up the recording loop. So we are going to loop to save char by char or byte by byte, and we are using this information, the number of words in a record. Also, we are going to use the new address to save, and that will be the first address, the address that we are going to use, or the first address char that we are going to use to start loading the data in the system. And using this information, both of them, we are going to record in a page, like from 1 to 26. After recording, we are going to update the new address to save, so the next address that we are going to use for saving, and also the number of records. So for reading the data, on the other hand, we are going to first extracting the number of records and confirm if the data exists. So if, for example, I recorded 5 and the user or the microcontroller is requesting 8 or 9, this one will block it because we do not have any data inside it. After that, we are going to get the number of record of word in the record, and this is to use it first of all to set the recording loop, so how many byte we need to read, and also getting the loading address. So using a little bit of simple math, we are getting both information, and using them we can start reading the data. That's the whole thing for the version 1, which is a simplified one about recording and reading using a certain logic. Okay, so let's take a look quickly on the MH board and the time logger that we are going to create. So we have been sharing this one for a few times now. This is a quite very cheap board, which is extremely interesting. So we do have the 2 chip, the DS3231, which is a real-time clock and with the address that I'm sharing, and the AT24C 32, which is a 32 kilobyte just for the information, and having on this address the on this board the address of the hexadecimal AE. So using these two one, and also it has a backup battery so it can keep the clock during that time, we are going to use both of them to save each time, like the timing each time the microcontroller is reset. So each time we are going to reset the microcontroller, the information will be saved on the in the EEPROM memory, and then we will know how many times the microcontroller has been reset and when it has been reset. Okay, so that's what we are going to do, and to do so we are going to connect our STM32F1 to the board like this. So a very simple one, so we will need only the 4 cables for the power and the ground power and also the clock and the data, and the other hand we are going to connect the STM32F1 to the PC using the FTDI. So doing so, we can now go and start making the support function to prepare our small data logger. So here we are, our fresh main file, so there's nothing written here yet. I'm adding the data logger header here, where we do have the C file with some commented part for this part, and also a header file with the SysTick, the ATC24 library for the memory management, and the DS3231 to get the date. Okay, so let's jump quickly to the support functions. So they will be quite very easy functions, but they will help us a lot to manage the next function we will develop within this tutorial, and to do not make us repeat ourselves. So the first function is returning a char, and it gets 1 byte, and so this is the byte position we would like, and it depends on the input. So I put it here as a long, but we still can put like integer or a short, but this is to keep at least the maximum number of bytes within this input. So it will be a very simple one. Let's call it result. That will be equal to a number. So we will take the number and we will move this byte by the byte number here, byte pos, multiplying by 8. Sorry, by 8. And this is means that we are going to move this number. We are getting the byte positions to the 8th time, which will get the byte that we need. Okay, and at the end we just, I have to put here as a char because it's only a byte. We are going to return result. That's very simple. You can even use it to like directly in the same program, but just to not lose, sometimes it can be a little bit confusing about the byte position, so this one will make it a little bit easier and quicker to do. Okay, the next one is, as we have been reviewing, sometimes we will have two addresses and we need to combine both together. So this is a simple one. So we are going to extract some data and combine both addresses so we can work with them. Very simple, very easy. So let's start making them. So that it will return a short because it's two addresses and we need to get the short. So first of all, let's put like this. And let's start work on it. So the first, we are going to put like short number 1, like no, let's put result as usual. Okay, and let's put it equal to 0 just to avoid any risk. After that, so there's two ways we can read one by one, and this is the one I prefer. So let's take a char we called num1 and also num2. And this is the one we are going to read using this function here. So the load byte function here. And if we go here, we are going to take the start address. So the num1 will be equal. So if I put, let's put it like this. I think it will be smarter to put it like this. So let's put equal like this. And the I2C, it will be the I2C. So we don't care that much. It will be provided by this one, and the address will be the address inputted here. Simple, like, and after that we just copy this one and we take num2, this one, and it will be address plus plus or address plus 1. Then what we have to do so is to take the short, so result will be equal, and here we add short just in case. So we need to change this one, and we take number here, number 1. What we need to do is putting also again result equal, so result that will be moved to the left by 8 bit or 1 byte, so we can get the first word or the first byte of this result. And after that, simple and easy, so result will be equal or equal to make it simpler, or equal to number 2. And like this we have created a short number from two addresses, and we just need to return, not result, yeah, we are going to return result. Yep. So what we have done in this small function is we are going to take an I2C and one address, and from this address we are going to read 2 byte or 2 char and combining them in a number which will be a short, and that's all. This is what we are going to do and return it, so we don't need to repeat this very simple operation many times. Finally, we are going to take the opposite actually, where we will have a short like this. We will have a short, but we would like to input this short inside the actually we put it as an int, and we would like to put it inside some byte addresses, so we have to cut it in different byte. And here where comes the function that we have created previously. So first of all we need to take the function here, so we need to save byte function. That would be very simple, and let's put this one first. So the I2C, same, depends on the I2C input. The short address will be depending on the address here, where for the value, so here we are going to use this function here. You see how things are get connected and easy to manage. and the byte position for this one will be the byte position 1, and the value that we would like to put is here. So, and here we do have a very simple way to input the information in our EEPROM in a very simple and quick way. So you can see now we have just to input the value here, and it will input it inside the EEPROM. Okay, that was the 3 functions that we are going to extensively use in the next examples. So now we can jump, no, sorry, actually now I will copy them in the header logger and we can jump to the next part. So now that we finished most of the support function for our code, we can start with the first one for the logger, which will be the logger init function. So this is the second part where we are going to create the initialization for the logger, and the input is only I2C. So as we have seen in the presentation material, this is the structure of the addresses and the information we are going to add, and as a version we are going to use version 1, and we may have a chance in the future to improve and to get further information, and this will be taken the page number 0, or the 32 byte that we are going to use. Also, I just added here, or enumerate some variables, so we can have the name of the memory register better than putting only the number, so we can easily get where we want to do, where we want to go without really remembering the number, and it will make more sense. So let's start quickly. It should be simple and straightforward. So let's put like this. And so first of all, let's go here and take this function, because we are going to write 1 byte at the beginning. Let's take here, and so for the I2C we are going to use only I2C. For the register address we are going to, this is the version 1, and the data, as we said, this is 1. Okay, so as a version 1. Okay, after that we have to input 2 informations here, which is the data size. So we are not going to use this save byte, but we are going to put memo update 2 byte, this function, so we can already start using this one. So let me close this, and we just put like this here. So for the I2C, as usual, the I2C will be read from the I2C here, and the address will be the memory, and this is how much memory this EEPROM has. And the memory is in, if we put it as a hexadecimal, is a hexadecimal number 0FFF, and this is the number that we do have it. Okay, and after that we are going to add the word size. So to add the word size we are going to use only 1 byte, and so the I2C, and this is not the version, but we call it word size. So this is already written, so you see how simple and easy we can catch up with this one. After the word size we need to put the number of record, and number of word in a record. So simple to, so we are going to copy this one again, and so actually for the word size here, why we're putting 1, because it's only 1 byte by word. Okay, I'm not going to use this option in this example, but maybe in a future application we will need 2 or 4 byte by word, so that will be very useful. And after that, so now after word size we need to check the number of words in a record, so how many bytes we are going to save. So this one is not a word size, but actually record size, or rec size, and we are going to need 8 byte by record. Okay, and after that, so this is a simple one, we can jump again to the number of records that has been already done, and we can use directly this function here and paste it here. So instead of memory, so we are going to go for the, which one, I already forget them, and this one, rec total. Okay, let's take here and we put rec total, and finally we are going to update the address, and we will need 2 byte for the address, and for rec total when we start it's a 0 actually, so it can be 10, that's more than enough. We can update this one again, and we put here not rec total, So this one will be 7 and rec address. So let's put rec and address. So this is the rec address, but the rec address or the record address, the first one that we are going to use is starting from the page 1, which is 32 or hexadecimal 20. Feel free to use whatever you want, but it can be so because we are starting, oh sorry, even because it's wrong, because we start from page 1, not page 0. Okay, that's fantastic, that's really great, but however that's good if we would like to use it once and then remove it. How about we add a small check or small if to check if we already have a version here, we don't want to change it. So we have to check first. So let's take a char and we call it a check, a simple one, and that will be equal. We go and we get some data here. So this one, let's go here, that's equal I2C, and we are going to check the version. Okay, yeah, and look quickly, and we put version. Okay, so if this check is equal to 1, because maybe we will need later on to confirm the version, so we don't do nothing, so if it's equal to 1, we have nothing to do, else we can start updating our version. So this is quite a simple program. So we initiated, you can see how quickly and easily we initiated our master logger, or the one that we are going to initialize how we are going to save the data. And also we check if we do have the right version, that's fine, else we are going to create from the scratch our memory. That's good. So now that we initialized our data, let's copy this one and put it in the header so we can jump to the next step. We just completed the logger initialization function, and this function will help us to set up the logger master. Now we can go and jump and preparing the logger record function. Okay, so before we start working on this function, there is something a little bit tricky that we need to talk about, is about how the EEPROM memory at the AT24C is structured. As we discussed, we do have pages, and one of the problems that we can have is that when we have to jump the page, we have to take a special procedure. So here we are getting some data, and we need to be very careful about if we are going to jump a page or writing within the same page. So saying so, let's start using this function. So this is a char logarec, and char, it will return 0 or 1, and this is if we have an issue or if we don't have memory, it will return a 0, and if this is fine, it will return 1. Okay, so we will work on this one later on, but first of all, let's start by downloading some of the data, special data about that. So let's have a short, and we call it the address, and the address will be equal. So we are going to use the function getShort here. So we are finally getting to use this really helpful function. So we are putting like this, and we are going to use the I2C, and we are going to have the record address. This is the last record address that we need. Okay, and after that we need also to get the number of bytes. So this is a char, and it will be, we can put it as a short, just later on we can change it, and that will be let's call it a size, quite simple, and it will be equal. For this one you just need to read, so this will be more than enough, this function will be more than enough here. Okay, so and for this one we are going not to take this one but the record size. Okay, so based on this one we need to confirm what is our next page. So let's have a short, we call it next page, next page, and this one is equal to, so what we are going to take, so the address multiply or divided by 32, and then we are going to add 1, and after that we are going to multiply everything by 32 again, and this is to check when is starting the next page. So it's quite very simple. So if my address here plus size together are bigger than next page, so this means that we are going to jump the page. So then we are going to use a special way of saving. We will need to use a certain logic. Else here, let's use the else, because the else is a very simple one. And let's go here. So what we can do, so for this one we need to make a for I loop. So let's put an int here, I. So for I equal to let's say 0, I less or equal to size. So this is, we are saving for all the size, actually not equal here, that's totally fine, and I plus plus. Okay, we are going to use the save function, the normal one. And why I'm trying to avoid to use as much as possible this function, because this is each time if we do a save and close, we have to wait for 20 milliseconds, which is a huge it's huge waiting time and consumption, so it's a big waste. So I2C, and we are not going to update version, but we are going to update address here, and also we are going to update address plus I, and the information that we are going to update is data of I. Okay, I hope this is quite clear and simple. So this is quite a long way, but this is a way if we do have this situation. There's a further logic, you can divide it, but to avoid any further complication, I'm just using this one. And after that, if that's totally fine, what we can use, so we can use a different function. So let's jump here, and we are going to load page. So we can load quite a much more data on this one. So let's go here, and we are going to put this one here, and the register is address, of course. Okay, let's put it here, and for the char or string that we are going to add is data, and finally for this one we are going to add the size. Okay, and here we could update our new information in both ways. If we do have the next page, so we will have to save byte by byte, else we can update everything in one shot. Hope this is clear for you guys. If you do have further question, feel free to ask me. I will be happy to give you more insight on it. So then we need to update address again. So address is equal, so it will be a plus equal here, let's put it here, so plus equal size plus 1. Okay, then so we need to update also the address. So we just put where is it, so we just update the address here, so we will have the last address to save on again. Yes, so we put here rec address, but instead of 32 it will be just address. Okay, after that we just would like to total on this one. So we need to check how many records we have made, and in this one it's quite very simple. We just use this get short. This one, it's a little bit like there's a function inside the function, but here I think this will be quite easy to understand. So we are going first to download this function. So how many, not address actually, but total. Yeah, it was almost a mess. So we are getting the number of total record, adding one, and then updating again in the total record. That's quite simple I hope that that's quite clear. So that's up to here. It's really simple and fantastic, but we can add a small security on this. So this is how we are going to save. But there's one thing extremely important that we should careful about, is about we need to check if we do have enough memory to save. So what I'm going to add here is we do know our memory, but if we do have a different part, so short, let's call it memory, and this will be equal here. So get short on this one, and we are going to check the memory here. Okay, so the memory is a static information that should not be changed. Okay, so we are going to put all this like this as in condition. So if we check here, if memory is bigger than address, so that's fine, we do have enough. So actually not address, but address plus size here. So if memory is bigger than address plus size, we can directly save, so there's no issue at all. Okay, and we can have small another int or whatever char. Let's put a char here. Let's put a char and we call it a check. That will be equal to 0. Okay, and let's put equal to 0 again. And here we put check is equal to 1. That means everything is going well. And else here, so if we do not have the memory, we put check is equal to 0, and we will have a negative input, so we have to return check. Okay, probably I have missed something. Okay, so if I add this one like this, we should be good. So if I close this, we do have a else. So we download memory, address and size, and we are going to use this one first to check if we do have enough memory so we can save. And inside the save procedure, we have to check if we do have enough, if we are going to jump the page, so we have to save byte by byte, else we can go ahead and save everything in one shot, else we are not able to check and we return a 0. Okay, that was the recording one, so we can jump to the next step. Now that we completed our record function, we can jump and create our logger read function that will read and extract the data from the EEPROM. So let's jump to the record function quickly. On this one, what we are going to do is going to get the I2C as usual, which record we would like. We may have 100 of record and we would like the number 35 just in case, and we would like to put everything inside the data. So to start working on this one, what we need to do first of all, we need to get the same information as a record function, so which are not the memory, so not the memory and not the address, but the size here. Okay, so the size of the number of record, and we are using this information to start computing. So we need to take short, and that will be the recording address, so we will call it address here, or the reading address, sorry, will be equal to size. So let's put the 32 because it's the 01 plus, like this is the 0 address that we are going to use, size multiplied by the number, the record number. Okay, so if it's 0, it will be reading 32 and go on. Okay, so based on this one, there is another information we need to check again, is if we are going to have the problem of the next page. So let's go here and compute the next page too, because if there is a problem of next page, we need to confirm it. Same also, if we do have these conditions, we need to use a special procedure. So first of all, if the size, okay, let's put int I. Okay, so if the address is bigger, so here we are not going to use this one, but what we are going to use is data of I, let's put it here, will be equal let's put delete here. So we'll have an equal here, but instead of reading this one, we need to have the get byte function. This one, actually, a simple one is the get, not save, but load byte. And let's go here. So this is the function that we like to change. We go to the get byte, and it will be this function. So we need to use the I2C and address plus I. This is how we are going to build it. Else, if we do not have any issue with the address, we can use the same function, this one. Here we are going to load page, and not the load page, but we are going to take, or it's the opposite, is, just a moment, this is a save byte, which is correct. Yep. And yeah, that's correct. Why I have load page here? Oh, so I have a mistake here. Yeah, so this one is not a load page, but we need to save page actually. Yeah, so ATC for save page, and this is what we need to do. Oh, okay, that was a big miss. Okay, but here load page is correct, so we are going to take the I2C and use the address, the first address, and then the data. So, and this is the size that we are going to read with. Quite easy and simple. Yeah, well, that was a good catch. So save byte and save page, where here we are going to load a byte and load a page. Perfect. So that's so far so good, but we need to confirm one thing. So if the number of record that has been shared here is greater than our number of records, so we should not read nothing. So we have to read this one. So let's not update, but to get short. And let's put here a short here, and that we call total record dot rec. That will be equal to the total record that we do have here. So there is an issue. Yeah, I don't need this one and this one. That should be fine. Okay, so what we are going to check, so let's also use, we will need to have a check that is equal to 0, like this, and let's move this one to here. Okay, so if my total record is greater or equal to the record number, then we can do this. And also, let's put this one here. We just start by putting check equal 1. Okay, and finally we return check. That's all. So we get our total number of record and check if the total number of record is greater than our record number. After that, if that's fine, we can load the data, whatever it's like a byte by byte if we do have a page issue, or loading the whole data directly as if we don't have any issue on that. That's clear, and quite happy that I could correct this one before we go to the live stream and coding. So let's add this one to the header and jump to the next step. By finishing the logger read function, we have our whole logic ready to be used, and we can jump now to have a live example and debug if there is any issue. Before to jump to the main C file, make sure that all the function that we work together in the data logger C file has been copied in the data logger, so we can use them directly here by adding the data logger .h file. And also we are going to need the UART communication, so we will need the UART drive. Before also start coding, let me quickly show you again the circuit. Nothing new, so we do have, this is our MH board which is connected to the UART2 of our STM32F1. On the other hand, we do have the this is I2C2 connected to the MH board. and this is the UART2, which is PA2 and 3 connected to the FTTI, which we are going to use the HTML program to read the data from that. Okay, so let's jump back to the program and work on this one. So first of all, let's make the initialization. So sysdig init, which will be just like this. After that, we are going to init UART init actually. So UART init, and we are going to use UART2 and the baud rate 115,200. Okay, and we need to make the I2C unit 2. Okay, and let's use the I2C 2, and for the speed it will be the I2C fast mode. Brilliant. So before going to the logger, let's check if we do have the right time, because we are going to create a data time logger for each time we are going to reset or restart our microcontroller. So let's check if the time is correct. So DS3231 here, and we need to get time. So we are going to use UART2, and the time that we need to use is so that string. So let's get timetable, let's call it timetable. Okay, so let's put here and add a string, an array of chars. So let's put a char and let's call it timetable. Okay, and it will have 10, I think 10 memory or 10 byte will be more than enough. And to visualize it, just in case, so let's visualize it using not UART. Before doing that, we need to convert it. So we are going to use timedate. So let's take timetable, and we would like to put the data inside time. So as an array that we are going to add, and also we put here time. So we would like to see a time format. Let's copy same, and if we would like here it's timetable, and let's copy this one again and add it here. And for this one we are going to put date, so we will create it later, and here with a capital letter date. So let's add time here with 12 byte, and also add date, which will have also 12 bytes. Okay, that should remove all the red and issues. So let's print time. So UART send, and we are going to use UART2 time. Okay, and after that let's copy this one and paste it twice. So we are going to add here a new line, where here we are going to add a date. Okay, so let's check if the time that we do have in our DS3231 is correct. So 0 error, 0 warning. Brilliant. So if we go build and load, we should see, okay, it's 8 p.m. and it's the 4th. It's the 10th of October. So if we check here, let's check in the actually it's in 11th of October. Let's go here. I just added a time here, so it's almost the same. So if I reset again, so let me first clear this one and I will reset. So it's almost same time at the second level, so we are quite good from the DS32. So now that we have a right time inside it, let's comment most of it. Okay, comment all this one, and going then we do have this one. We are going to initialize the logger, so logger init, and we are going to use UART2. Okay, and after that we are going to need to check if the data, like the initial logger master, has been correctly done. So let's have a check. So let's have an int I here and try to read what has been logged. So let's go and make for I equal to 0, I less than 10, for example, I plus plus. Let's read the data. So we are going to use a UART. It will be UART TX2. So we are visualizing what we are going to read. So we are going to read the AT24C, and we are going to load a byte each time. So we are going to use I2C2, and after that the register or the address that we are going to read is I. Okay, so let's close this one. We should be ready to read. Okay, so everything is clean. So let's save, build and load. So let's check at the hexadecimal level. I think there is an error here, yeah, and another error here. So this is probably coming from, so when we created, I think the get short is correct, but if we go here, actually this one should be 0, and the address, we have to put address plus 1. Be careful about this mistake. Okay, I made a mistake here. So this one should be plus 1, where plus, okay, this is a plus 1, and this one must be 0. Okay, should be good now. So let's clear, and if I save, build, okay, some error did happen. Let's check where is the error. Where's my error? Okay, something is not correct here. Oh, I forgot to add this one here. Okay, that should be good now. Okay, and also just to crack a bit this one, so let's put, so because I already, if I load here FF, this one is wrong, so but let me push this one to 0, so it will overwrite it anyway. So let's save, load, and brilliant. So we do have here, with the total memory is the 4092 registers, where we do have 8 byte data, 8 byte data, and we start from the 20, the memory number 20. So let's put this one 1, and we should be good. So now our logger master is ready, and we corrected a small mistake happening here. Okay, so the next step would be to, so we already have this one. When we get the time, we would like to record the time, and let's confirm it. So get, actually we have to use logger record. We are going to use the I2C2, and we would like to save or record the timetable. Okay, so this is done, and also let's change a little bit here, and we are going to read the master after loading this one. So let's save, build, and load. Nothing did happen. Okay, let's go to the debug mode and check what's happening. So if I jump one by one, okay, if I go here, so you see this is happening a lot in the AT24. So when I start making the initial tests, the AT24 needs always some delay time in the functions. So if I go back here, and I go to the AT24, so I do have in the save function a 20 millisecond wait, but I'm quite sure in the load function I didn't put, and this can be one of the reasons of the issue. So let me add a 20-second delay each time, and let's save, build, and load. We do have it now. So you can see here I do have one record, and the next address that I will get is 29, which is brilliant. So now what we need to make is try to read the data. So at this time, I think this one we can comment it. and start reading the data. So we get logger read to, and we need to have a new variable. I will call it save, and I will give it here 10. So save is like 10 byte maximum. That's more than enough. And I will increment this one. Let me, okay, I forgot something. Yeah, I need to put like save 0. Okay, and start. So instead of timetable, I'm using the data that I saved in the EEPROM or in the memory to get and check what's happening. Okay, and let's run build. I'm removing this one, and if we run like this, let's see, I'm removing this. That's fantastic. I do have now my memory. But if we go back here again, there's a very important thing that we need to check. Let's save. So I should better clear this one and add a new line before start doing this, so we don't get any confusion. So let's take a look. So I already saved 4 times, and the address that I have to read from is 44 hexadecimal. Brilliant. So let's now start reading all the data that I have saved. So let's comment this one because I don't need it. So, and let's have a message here. So let's go UART, let's use this one, UART send, and instead of date we will put, so let's add a /n and the number of records. Okay, we put like this, and we need a small another byte, so num we call it, and we put 12 here, and let's read some data. So let's put here dot rec. Okay, so dot rec will be equal, we already have the number, where is it? It's within this function, and this is a total record, so we need to read total record and just this one, so get dot record. Okay, so let's put this one here, and instead of I2C we are going the I2C number 2. So we need to convert int to char, so it will be the dot record, and that we will put in the num here, and after that we are going to UART send here, and let's put UART 2, and we are going to send num. Okay, brilliant. So we can also add a small one, not this one, small line just to make the gap, to be sure about it. Let's put here and /n here, and a few ones here, and another /n. Let's make it a little bit longer to be sure that there's no issue, and we don't need that one anymore. So save. Let's clean this one. Let's remove the hexadecimal, and if we load, so we do have total record. I think I mistake the new line character, which is a shame. Let's clear, and I should now, if I load again, okay, we have 6 record, and we do have this one. So now what would be great and really good is to again, a shame, so let's add this one here. So we create a loop, so from here, and let's not this one, let's create a loop for I equal to 0, I less than dot record, I plus plus. Okay, and we are going to read each time. Okay, so we put this one, and we need to put I here. Okay, and just to make sure that we can understand a little bit more the data, let's add this one at the end of each time. And don't forget, this is extremely important, and doing this would be a little bit annoying. You have to empty each time the time and date arrays so you can input again. Okay, and let me save this one, copy and put instead of this one, and I'm going to put date. Okay, so let's save, build, and clear here just to have a clean picture. And I have all my records. However, this is a correct one, but something is getting wrong. So we confirm that record is going well, but I'm quite sure the problem is coming from reading actually. So when you read the data, actually the new address is not this number. The number that we need is not 32 plus the size multiplied by the record, but we need to add plus the record number. So each time we multiply, but plus 1 for the record. So if we do like this, and let's clear everything, save, build, and load. So you can see now all the numbers of record that we do have, and the time is correct. So let's go further. So now that we saved, let's take a look. So each time that I will reset my STM32F1, a new record is coming, and we do have the records each time, and we can track now how many times our microcontroller has been reset. That's all for this tutorial. I think we had quite a big debugging session, but really worth it to understand what's going on. I hope you enjoyed this one and you see how powerful this small like the data logger that we do have. Thank you so much, and see you for the next episode.